Yes.
Okay, so I guess we're live.
Yep. All right.
Can I collapse this somehow? Oh, well, let's do this then. Okay. So. Does this show up well? Can you see my slides?
It looks good to me.
Yeah,
Cool.
yeah, it looks good. Yeah.
Okay, so thank you very much, Jared, for organizing this. It's really a pleasure. Like I haven't done a talk in, I don't know, over 6 months, and I usually get a bit nervous. And I've tried to do this as best as I can, but if there's any problems along the way, or if the demo doesn't work perfectly, I'm sorry. I just kind of did the last moment, and there could be bugs in it and everything. But I'm going to do my best and make sure everything sounds okay. So yeah, today I'm going to talk to you about integrating the Envoy gRPC API into the Dynamic Service Discovery Platform. And this sounds like a very pompous title, but I'll go into a bit more detail and explain to you what this actually means and why this is not such a hard concept to grasp. How do I, okay. So a bit about me. My name is Mihai Todor, and I'm a senior software engineer at Cogito, and I'm focused on highly scalable distributed systems and on using Go for building them and designing them. I do quite a lot of things, like, for example, having some monoliths that needed to be made more cost efficient and more, lower latency and such, and use less memory and things like that. So the idea was to design a new system, put it in place, have something like, I'm kind of going to assume here that you have familiarity with things like cluster managers, like Kubernetes, or at least you've heard of them. So like, coming from statically deployed hosts in the cloud, in Amazon and so on, and going to like a fully dynamic cluster manager, Kubernetes, everything runs in Docker containers, has memory limits, CPU limits, etc., health checking and so on. And all these things are either provided by the cluster manager or something that sits on top of it that does a few more things. And I'll talk to you about service meshes. So what is a service mesh? And let's start with the beginning. Like, let's say you had a WordPress blog. It was running somewhere in your, I don't know, on your laptop at home, and you had a public IP and people were accessing it from there. And, it was kind of like okay for a while until you had like more people coming along and you wanted your site to be available all the time, and then your laptop couldn't cope with it anymore, so then you put it in the cloud somewhere. But then in the cloud, you only have one instance, like servers go down, and then you have to bring them back up. It will wake you up at night. You don't want that. So what you want is to remedy as many of these issues as possible automatically. So this is where a service mesh would come in, because like, imagine you have multiple services in your backend, they talk to each other, but there's reliability issues, like the network goes down or whatever, you want to do retries. You implement that in your own application. Let's say you have like PHP code, you have Python code, so on. You want to implement all these retries in all these different languages? No, you don't. You want something else, like an infrastructure service, to handle that for you. So service mesh basically looks at all these common patterns that are developed in many apps, like reliability, security, observability, and management, and gathers them in a common package that is deployed across your cluster. And this is able to handle all of these things for you automatically without, like having different versions of different libraries implemented in different languages that are not perfectly compatible with each other, or that have issues when it comes to like having to upgrade them and so on. Like, you just pre-deploy your service mesh and everything gets the same version of the same retry or the same telemetry, things like that. And I can give you some examples of well-established service mesh solutions. There's Istio, Consul, Linkerd, Kuma, and Mesh. I'm not sure how to pronounce that. And all of these are kind of similar. They have pluses and minuses. There's some, I forgot to paste a link here. There's a place where you can kind of see a comparison between their features. And by the way, please feel free to interrupt me at any stage if any of this is unclear, or if I'm saying anything silly, just please let me know. So there's all these solutions out there, and they're pretty complex. Like right now, we're in the process of using Istio at my current job, and the first crude attempt of just launching it on a laptop and seeing kind of how to interact with it, that was like pretty difficult. Like it ended up using about, I don't know, 8 gigabytes of memory, had trouble starting up and also things like that. So, oops. So that wasn't great. And, you know, it's like super complex. It has many knobs that you can adjust, many settings. Services need to be written a certain way to work with it. You have to write some definition files, usually in YAML, that describe what your service needs to support and like how it health checks, what kind of retries you want to do, what kind of resources it needs, things like that. So it can be very complex, and it takes a while for people to get adjusted with it. And you probably need more than one person to do this job, like to have it fully deployed, troubleshooted, understood, and so on, and have the right run books such that everyone can deal with it when things go bad. And things do go bad. Like even Istio, for example, made a big change in a minor version, and they just released an update, and you know that just broke everything, and people pulling hairs out for a few days trying to figure out why. So these things are very complicated, and people have been trying to understand the patterns and make them more user-friendly, but it's still kind of a work in progress. And you know, like when this thing started, there were other projects along the same path which try to kind of abstract away some of these concepts. And you know, they're smaller, they have fewer features, but they're way easier to reason about. And before yeah, there we go. And the next thing to talk about is the deployment models of a service mesh. So one way to do this is to have on each node in your cluster this kind of process running that does all this orchestration for you and has all this abstract concepts placed in there. So for example, it might launch a proxy that lets your services talk to each other and be proxied to an ingress, or it might take care of all the telemetry, do health checks, things like that. And then, for example, in the case of Istio, or I think Linkerd as well, you have the sidecar proxy deployment, which is each instance of your service running on a node in the cluster will get this sidecar running next to it. So then you'll get this executable that is, or a container that is going to run alongside your application container and take care of all this infrastructure for you. And there's a link there that I pasted which gives you a lot more detail about this. Like, I'm not an expert by any means in service meshes, and you know, you're welcome to read about it in detail if you wish to. So let's talk about sidecar. So what is sidecar? So sidecar is not a full service mesh. Like, you can say it's a bare bones service mesh, but not really. Like, for example, it doesn't handle security. It doesn't do much telemetry. You know, it's kind of simplistic, but very easy to reason about. So its features are dynamic service discovery, and it's Docker native. So then it basically looks at the Docker socket and figures out what containers are running. And based on those, it figures out what kind of services you have in your system and where they need to be proxied to. And it does per host proxying via either hub proxy or Envoy. And the way this works is it just like figures out, okay, I have any instances of this service. I'm going to tell either hub proxy or Envoy, depending on how it's configured, hey, can you please proxy this for me and you know, make it work and do this number of retries or whatever you set in the configuration there for either of them. And then it also supports this health checking. So it looks at Docker containers. They have a port exposed that contains like this kind of health information. So then you can just see, okay, is this container healthy? Is it healthy? And just pause for this information every few seconds, or depending how much time you configure for that. And once it returns unhealthy, you know, it tries a few more times, and then once it's fully unhealthy, it removes it from the proxy, and then requests can no longer go to it. And depending how you configured your cluster manager, because sidecar was meant to kind of run on Mesos, but it's not necessarily tied to Mesos. You can run it on other cluster managers if you wish to, or you can run it as fixed deployments on fixed nodes. But the idea is like you have sidecar there, it does health checking, it instruments a proxy or Envoy to do proxying, and it also establishes this gossip-based communication between all nodes. So imagine kind of all nodes become aware of each other, and in this kind of viral fashion, as soon as you add a new node, it just spreads, sidecar spreads information throughout all the other nodes saying, hey, there's a new node coming up, it has the services here. So if you need to do like, for example, service to service communication, you have, you know, one instance of service A trying to reach service B, which has 10 instances. It will do that through Envoy or through a proxy. So, oops, sorry about that. And a bit about sidecar's history. So sidecar started in New Relic back in 2015. Carl Matthias is the author of Docker Up and Running, and you know, pretty cool techie. And he started developing it there. And you know, when he moved to Nitro, which was my previous employer, he had already a pretty mature solution, which was good to just put in production. He said, okay, let's have a Mesos cluster, let's put sidecar there. And we had our own very little kind of service mesh system. So this thing was running very good in production. We didn't have that many issues. It was very easy to launch services, do automated deployments, and everything was working kind of smoothly. Of course, there's like issues down the road, like you want to have a more reliable system. Like whenever you do a new deployment, you don't want to like have clients disconnect and have users impacted by your deployments. So then a part of that was to enable tracing between services. So you have like a request coming in from a user, you want it to go to service, well, it goes first to your ingress, then it goes to service A, service B, service C, until it finally gets the response it needs, and then it goes back to the user. Now, along the lines, you know, you can have some unreliable service, you can have a bit of flapping happening there. So what you want to do is to kind of detect this using tracing. So then Envoy is one of the things that gives you this out of the box. Then it was decided, hey, let's modify sidecar to support Envoy. And then he moved on from Nitro, went to community, and continues to support sidecar. And I'm also kind of fond of this system, so I continue to support it myself. And I recently integrated the Envoy Go control plane into sidecar such that we can support the new Envoy APIs, because the initial version was using the now completely deprecated and dead REST-based API, JSON-based, and you know, in order to use the newer versions of Envoy, we have to switch. So here's the architecture to give you a full picture of what's happening in a cluster. So you have the internet where users come in and do requests. You hit an ingress box. For now, you know, it's just one box, but imagine it can be multiple boxes that, you know, kind of do a sort of load balancing. And then the ingress figures out where this request needs to be forwarded to which backend. And the way this works is that each of these systems have a sidecar installed, and oops, sorry. So each of these systems have a sidecar installed, and sidecar establishes this gossip cluster, and then each Envoy on each of these boxes, including the ingress, is aware of all the instances of all the services that you have running in production. So in a bit more detail, we can see the traffic highlighted here. So I took a snapshot of the ingress and of one of the backends, and I'm showing you what communicates with what. So we have the internet, we have a request coming into Envoy here, represented by this green arrow, and then Envoy figures out, okay, this request needs to be forwarded to which service, either on this backend or on another backend. Once the request hits a service here, it might need to hit some other service, you know, just continues the flow. So then this service will talk to the local Envoy, will figure out, okay, Envoy figures out, okay, this needs to go to service B or service C, so then it might forward it to either the instance of service B running on this backend or another backend. And then Sidecar performs Docker discovery and health checks via this red arrow here. And then we have Sidecar sending Envoy updates via this orange arrow. And then there's also this thing called Envoy UI, which is a Crystal app, which is very simplistic. It basically gives you a proxy-like view of what's running in Envoy. I'll show you how that looks like in a second. So now for a demo. And by the way, I went a bit fast here, so let me know if I kind of confused you in any way. Okay. Hope everyone can. Can everyone still hear me? Is everything okay? Okay.
So the question here is like the services that I see here, those are like pure Kubernetes service endpoints, right? Those are the service endpoints.
Yeah, well, yeah, if you deploy pods in Kubernetes, you can view them as the services here. Yeah.
Right. And so what I see is we don't need any additional components like pilot or whatever the Istio has. That's not needed. That keeps it sleek and efficient, basically. Okay.
Exactly. It's very simple. Like it's not trying to mimic Istio in any way.
Right.
Like the only thing that it takes from Istio is Envoy, which is kind of separate anyway.
Right. So main responsibility of sidecars is to establish the mesh by using the discovery. And then everything gets routed using the Envoy at the bare minimum level. Okay, perfect. Yeah. Thank you.
And by the way, Pilot under the hood also uses this thing called member list, which Sidecar uses. Member list is a library from HashiCorp, and this establishes this gossip protocol.
Cool. Yeah, that's good to know.
Okay.
Cool.
So let's see. So for a demo, I wanted to simulate this cluster on a local laptop, and I used Docker in Docker. So please don't laugh. It's going to be interesting. It's also called DIN, Docker in Docker. So we're going to have one ingress node or container that is running the Sidecar listener mode. So this is only listening for updates from the rest of the cluster. It's not pushing updates in any way. It has Envoy with static listeners and ADS, aggregated discovery service. And it has a container running Envoy UI. And then we have 3 backend nodes, or we can add more, that are running Sidecar listener mode. Sorry, this is the typo here. It's just Sidecar, not Sidecar listener mode. I need to correct that. Then it's running Envoy, again, without static listeners. I just copy pasted. So it's basically Sidecar Envoy UI. And I'm running this WhoAmI service, which is a very simple service. It just bounces back to you the HTTP headers that you sent to it. And I'll do a demo of that. And I'm running 3 WhoAmI services, and there are 3 containers on each box. So one is WhoAmI TCP, and the other one is WhoAmI 1 HTTP and WhoAmI 2 HTTP. So these are 3 containers running on each backend, and they represent 2 services. One is the TCP WhoAmI, and the other one is the the HTTP WhoAmI. So let's have a look at this. Yeah, I need to correct the slides.
While you switch over, I'm gonna do some host maintenance real quick. So as you get it set up, okay.
Okay. But I'm still sharing my screen, right?
Mm-hmm.
Okay, cool. So first of all, I put together some bash scripts that can be a bit scary, so don't look too much into them. I'll provide links to them after this. But this is basically to help me set up this cluster that I described. So all of this is going to be run pretty easily following this script that I have here. So first of all, I'm starting the clusters. This is starting the 3 Docker in Docker containers. They're up and running. They're proxying a few ports. So for now, let's just ignore this output. We see our ingress up and our 3 backends. And then we want to start our services. So let's go and do that. So this is going to take a bit of time. It actually needs to pull the Docker images into each of these 3 thin containers. So it's a bit of a lengthy process, but hopefully should end in about 1 minute or so. So the issue here is that sidecar needs to have a seed node and the first, or seed nodes, but one of the nodes needs to come up first. Otherwise, you can risk ending up in a split brain situation where you have multiple of them coming up at the same time and they can't really decide which is the exact cluster of sidecars. So the trick here is to bring one of them up and then you bring up the rest. And then here we can already see that it's trying to pull the infrastructure services. So we have sidecar, Envoy UI. So this is going to work fine. And now it's creating these containers. And now we do the same for the ingress node. So this is kind of a separate node on which we don't have backend services. But already our backends should be up and running at this point. My script here does a bit of magic health checking just to make sure everything is up and running. Kubernetes people are going to laugh at this so much, but it was fun to write it. So now we're already running our backend service, or UMIs. So we can see here a summary of what we did. So we have 3 backends with sidecar, Envoy UI, and Envoy admin. We can access this and have a look at them. So let's look directly at the ingress. So in the ingress, we have the sidecar UI coming up here. And we can see we have our list of hosts in the cluster. Ignore the fact that hub proxy is here. This is a UI bug, it needs to be fixed. And we can see our 3 services that we deployed, UMI HTTP1, UMI HTTP2, and UMI TCP. And if we click on details, we can see that we have 3 instances of each of these services running on the 3 different nodes. So all of them are alive. The health check has worked successfully. So we can actually go and play with them. So we can do a docker exec -it backend to sh. So we can see them running here. Okay. So we actually try to talk to one of these UMIs. So we can go I think I need to install APK. And the port for one of them is, for example, this 132. So we see our headers, the request headers. Now this is talking directly to that container, but we know that we have like UMI HTTP1 is forwarded on port 10,001. This is basically the service port. So this is the way to achieve load balancing. We have multiple instances of this service, and then through Envoy knows that there's 3 instances of this, and we'll just load balance across them. So if I hit dev.local this, then I get, depending, on the various load balancing metrics in Envoy, I get a different host each time. So you see how this changes. And, it's just doing load balancing. So even if I'm on this box, on this backend, I think I'm on backend 2, even though I'm on this box, through the local Envoy, I hit any of this random UMI instances of this HTTP1 service. So then I might hit the one on this local box, or I could hit any of the other services. But now what we really want is to hit this from the internet, from the outside. So then I'm going out of this container. And let me just see, I don't want to diverge too much from my script. So remember, we have one TCP instance of UMI, which is on port 8888 on the ingress proxy. So let me just show you that. So our ingress is proxying here 888 TCP. So we can do that. And we just get the bare headers. We don't see any Envoy in there because Envoy doesn't add any headers for TCP proxying. It's just a simple packet forwarder. Or we can query for our HTTP UMI. So we pass in a host. And the host is basically telling Envoy, hey, if you see this particular host, forward it to this service type, to whoami1. If you see this other host, forward it to this other service, whoami2. And we use the same port for that. So either whoami1 or whoami2. Hope this makes sense. So you can already see that Envoy is doing something in here because it's putting these headers. And if we hit it multiple times, again, the host name keeps changing. You can see that here because it load balances across the 3 instances. Cool. So now what if we just want to add a new service in the mix and just enable that? So first, we're already on backend 2, and I want to show you the sidecar UI so you can see exactly what's happening. Whoopsie. Here we go. So we have one sidecar here. So this is remember, this is the ingress sidecar. You just put them side by side here so you can see it come up, hopefully, if I don't screw anything up. And backend 2 sidecar. Okay, wonderful. So now, we're on the backend 2 host, and we want to see this new service coming up. So the way sidecar works is by using Docker labels. Whoopsie. So it looks at the Docker labels that are configured, and it tries to figure out, okay, here's the service name. So I need this service is a part of this. So this Docker container is a part of this service that we're launching here. It needs to be proxied on port 10,003. It does have HTTP get health checks, and this is the container we're running. So now I'm starting it here, and we should start seeing it in sidecar pretty fast. It takes 4 or 5 seconds, I guess, ish. So first of all, it shows up as unhealthy, and now it's healthy. So we're good, we're in business. It came up. So now we can play with it locally. So right now I'm curling it through Envoy. We can see Envoy is proxying it just fine on port 10,003 exactly as we wanted. But now we want to proxy it via ingress. So how does that work? Well, I want to do it like this. Oh, that doesn't work. Why? Well, first of all, we have to tell the ingress that there's a new fixed listener that looks at this particular host, and it needs to proxy to this particular demo service. So how do we do that? We look into our ingress config of Envoy, and I already had this written here. So this is the Envoy config is very verbose. Like you can see, there's a lot of stuff in here. I'm not going to go over all of this. It's kind of maddening. But the idea is that I added this new virtual host to my fixed listener that I configured here, the HTTP listener, and this proxy is whoami demo local for the host header whoami demo local. It proxies it to this service on port 10,003, and then this listener listens on, where is it? I think it's port 10,000 somewhere here. Yeah, here's the HTTP listener port. So now we save this. And although Envoy can do hot reload, I haven't dug into that. So the way I'm going to do that is by just being mean and doing a docker exec ingress docker restart Envoy. So you see, I'm going into the ingress container and I'm restarting the Envoy container in that container. So now I restarted this, so my curl should start working, hopefully. Okay, so now we're proxying whoami demo. And I talked to you about the Envoy UI, so I want to show you that as well. So the Envoy UI for the ingress looks like this, and we can see exactly what we're proxying here. Mind you, this doesn't look at the fixed configuration I defined for Envoy. It only looks at the dynamic one. It should be enhanced. It's an open source project. It's on the Nitro GitHub Envoy UI. If you like hacking Crystal, by all means, we accept pull requests. But this gives you a very good overview of what's already in the cluster and what Sidecar is seeing here. So we know exactly what Envoy is proxying. And did I have anything? Oh yeah, the Envoy admin, you can also see that one if you're interested. This is kind of a boring admin, like this is the out-of-the-box Envoy admin. And like you can see kind of a config dump and some clusters, like the backend clusters, but there's no proper UI for it. So that's why this exists, it's much nicer. And that kind of concludes my demo. I can play a bit more with this. Like for example, I can show you what happens. Let me actually show you that. Sidecar. So what if we kill this demo? Yes. Can I figure out? Yeah, this one. Do docker stop. Boom. So now this should go away pretty soon. See, it's becoming unhealthy. And then tombstone immediately. So tombstone means that it's removed. So now we shouldn't see it anymore in this view. So it's gone from here as well. So Envoy doesn't know about it anymore. And our curl request should start failing again. See? Cool. So, okay, that kind of concludes my demo. And I want to go back to the slides. So there are multiple Envoy APIs. There's the old REST-JSON API that we had initially implemented in Sidecar. This is now deprecated and no longer supported for new versions. So there's the V2 API, which is gRPC based. This is already going to be end of life at the end of this year. So they kind of have a very aggressive cycle of changing major versions of the API. I did the work to integrate this V2 version, but V3 is already kind of out there and it's supported as far as I can tell. So I can probably go ahead and do the small modifications to get the V3 working as well, because this is going to be deprecated at the end of the year. Also, contributions are welcome if anyone is interested in that. And how do these APIs work? So the Sidecar and Envoy states are designed to be eventually consistent. What this means is that we get updates from the cluster, there's some flapping happening, things come alive, they go back as unhealthy, they become alive again. But after a few seconds, we kind of expect the cluster to be fully propagated, every update should be merged, and Envoy should know the exact current state of the cluster in a few seconds. For the V1 API, we had Envoy configured to pull the whole state from Sidecar every 4 seconds. So every 4 seconds, just tell, hey Sidecar, what's the current state? Hey Sidecar, what's the current state? And he kept updating its state. Now the V2 API is a bit different because of you have to integrate the Go control plane into your mesh solution into Sidecar, and that is a gRPC server. So then the Envoy has a gRPC client, it talks to this gRPC server. But the way it's designed is that Sidecar every second looks at its internal state, and if it sees that there's an update, it will just release this update, and then Envoy is going to be able to fetch the new state. Otherwise, Envoy doesn't fetch anything, so then it doesn't waste cycles, getting updates all the time, even though that update is the same state as before. Alternatively, we could send an update on each state update event from Sidecar, but that can be problematic because it can have spurious updates. 100 node cluster, you can have like a lot of things going up and down if you deploy something and then just overwhelm Envoy with 1 million updates, and you don't want that. And if you miss an update, then again, you can end up in this weird state where you just had an update come along, it was somehow missed, and it's not retransmitted again. And then maybe for a few minutes, Envoy just doesn't know about the updates, so you have problems. And this is kind of hard to tackle. So perhaps the current model is the best. I don't know. I don't run things at a large enough scale to tell, but I know it's inefficient. Like you can make it more efficient than this. So again, yeah, it can be expensive to send the whole state. And there's something called the incremental XDS in Envoy, which lets you send like, not the whole state as it is, like all the clusters, all the listeners, but you can send like, hey, there's a new cluster. Hey, there's a new listener, and so on. But then you have eventual consistency considerations. Like if an update is missed, is your current state in Envoy consistent? Maybe not. There's some documentation that I linked which explains how you can achieve this. There's some pretty complex state diagrams in Envoy that you need to respect. I guess Istio and a few other projects are either starting to use this or are using it already. I'm not sure, I have to check, but yeah, it's not easy to get right. And the Go control plane still hasn't implemented this. It's work in progress, probably get it soon. Now to dive a bit into the code, I'm not sure if everyone kind of wants to look at this in detail, but you need a few ingredients. You need the XDS server, you need the gRPC server, and then you combine this together using this register aggregated discovery service server. Blah. Anyway, this is what the Go control plane offers out of the box. And then you also need a resource cache. So the resource cache is basically a way to give you listeners, clusters, and a few other resources that you can populate into this cache and then attach a version to each of them. And if that version gets incremented, then Envoy is going to be told, hey, you know, I'm releasing this watch. So then Envoy is told, hey, you know, get this new version of the cluster, or get this new version of the listener, or here's the new listener for you. And there's a node parameter that you need to set in the code. Let me see if I link this correctly. Not sure if I did. Okay, this is the, anyway. The idea is that there's a node parameter for this cache. Maybe I can see it here. Ugh. Okay, I won't dig too much into it. It's, I think it's in the simple Go. Yeah, here. So you set a snapshot and you take in a node. And the thing is that node parameter absolutely needs to match what you passed in as service node to Envoy via command line. If they don't, Envoy just ignores your update happily and doesn't tell you anything. And this bit me in the ass a few times. It's so frustrating because you just don't get any error or anything like that. I think this is kind of a design thing in Envoy where you can receive updates from multiple things, although it doesn't need to listen to them. And yeah. And Envoy also validates the clusters by default only for the HTTP connection manager listeners. So for TCP, it doesn't care, but for the HTTP connection manager based listeners, it does care. And if you push a listener to Envoy that doesn't have clusters behind it, or it references clusters that don't exist, and clusters in the Envoy terminology mean services. So what I was talking before to you as I have a service which has 3, 5, 10 instances. This is a cluster in Envoy, which has multiple endpoints behind the scenes. So the endpoint is basically an instance of the server of the service. I'm going to confuse this terminology to death. And anyway, you have to bring up that cluster first before you add the listener. I just noticed yesterday that there's a validate clusters parameter that you can set to false, and then it just works without having to bring up the cluster first. That was very annoying. So maybe there's a way to optimize the code in Sidecar so I don't have to do this, you know, jungling around of listeners and clusters to get it to work. And testing strategies. So you can mock the Go control plane. You don't really want to. It's kind of large surface area and you don't want to re-implement it in your tests, but you can mock Envoy itself. So you can like spin up a gRPC client in your tests. And then you have to pass this nonsense along. So nonsense are some sort of Envoy terminology. I haven't dug too much into the Envoy code to figure out, you know, it's C++, pretty complex. But the idea is that it needs to be a monotonically increasing sequence. So you just, you know, you send an update, Envoy or your mock Envoy receives it, it just increments this nonce and sends it back. And then each time you send an update, you have to keep incrementing this nonces. But anyway, it makes testing very easy. Like this is my mock Envoy really, it's just, what, not even 100 lines of code. So this wasn't too bad. And I was pretty happy with, you know, just doing this and then being able to assert that whatever I'm getting back, the state is consistent. So this enabled me to write very easy tests. And also Go makes it trivial to inherit all the members of a struct. So I'm not sure if you're familiar with embedding in Go structs, or maybe you are, I'm just being, anyway. So the idea is you embed a struct in a struct, and then you just override the desired methods as needed. So if we look here, you know, like, oops, sorry. If we look here, so we just use a wrapper around the snapshot cache that we have from the Go control plane, and we just add a wrapper on top of test snapshot. So, eventually we call the built-in one, but we do a bit more handling around it to have this kind of state machine so we can do various assertions at each step of the update of the cache. So this is a nice way of testing things. I'm not sure if you're familiar with behavior-driven testing. I'm still fond of the Go Convey framework, which is kind of legacy now. People are not really sending new features to it, but I still find it very handy and I like to use it. I guess you can go to Jinko, Gomega if you prefer that, but I haven't used it extensively yet. I'm still using Convey and I'm happy to write tests in Convey. And thank you. That concludes my presentation. So if you have any questions for me, please let me know. And thank you very much for listening. Hope you found this interesting. Hope this gives you a slight idea of how to implement this like to take the Envoy API in the Go control plane and build it into your application and send updates to it. I gave various references there as links. So if you want to look at the code in exquisite detail, you can. You can also see, I think I put a link in, here. So this is the pull request where I integrated all these things into Sidecar. So you can feel free to, review this. The verbose part is the adapter part. So, this is where I construct all these objects that need to be sent to Envoy, and they can be very hairy. Like there's a lot of knobs you need to tweak and such, and things get complicated. But anyway, that's basically what I had to show you. Thank you, and let me know if you have any questions.
One question is on the side of you are supporting Docker, right, natively.
Yeah.
So does it mean that it's like if I have my containers on Containerd, will I be able to adopt it, or it's currently Docker only?
Sidecar doesn't support anything else but Docker, so no Docker API.
Right.
If you can't talk the Docker API, then it's not going to support that. But you can just put it in. Like it's a single file in Sidecar. Like just create a port, send the PR.
Yeah, cool. Yeah, makes sense. But this is very good. I mean, I have a good start. I'm very happy to see that no side components needed, and this can be brought up like very quickly on the local laptop itself. I'm very happy with this.
I'll put a link to the demo and stuff so you can have a look and detail.
Sure. Absolutely. Yeah. Thank you.
Yeah, welcome. Any other questions?
I have a question. I'm just kind of curious to know, like, what are generally like the cons of using a service mesh?
The cons of using a service mesh?
Yeah.
So, well, first of all, it's complexity. So you do need a dedicated team of having this system implemented and deployed in your infrastructure. It's not like if you're running a very simple small cluster with a few instances in Amazon, I wouldn't recommend it as a solution just because it will take you a lot of time to develop this, and you're probably better off doing things in a quicker way via some Ansible or whatever. Of course, this is down to the road of like creating custom infrastructure and deployment models which become unmaintainable over time, and then people need to do a very painful migration. But I think that starting from scratch with something like Istio is going to be very difficult for a small company. I'm seeing it in my company, which is about 150 people and quite a few engineers, and still it's difficult. It's not something you can do overnight. It takes months. There's things that you need to test. And if you even have a look here at all these knobs that you can adjust in Envoy, there's built-in sane defaults that they encourage you to use. But there's many things that don't have a good default and you just have to configure it, or there's things that have a default that works for some people like Google, but they don't work for you. So you have to go in there and adjust it, especially timeouts and such. And, figuring out all these things through the documentation is not going to happen. You actually end up digging into the code, seeing what happens, and it's a very painful and, tricky process. So even Envoy is very complex. I would actually suggest, using something simpler like Nginx or Haproxy as a proxy initially. And that's, way better documented than, or it has more years of being out there and people are way more experienced with it. So you can get started easier. Not sure if that answers your question.
Yeah, thank you.
Okay, anyone else?
So about when do you start to see the benefits of this setup start to pay off. I know it takes several weeks in order to get it all put together and configured and ready for a particular production setup. But if I'm selling it to a team, like how do I make the argument at point T? We will start to see the benefits of the system, either in productivity or stability or what have you.
Right. So once all of this is set up and you have the right build pipelines, either you have some sort of Jenkins set up or you have drone or whatever. The idea is that you can follow the whole DevOps mentality or concept and just you write some code, you commit it to Git, you create a pull request, the pull request builds it, it deploys it to a dev environment, then it gets reviewed, merged, an automatic deploy is triggered to deploy it to staging environment. Maybe somebody mucks with it there, and then it gets triggered again to be deployed to production. You don't want to deploy it to production completely just like that. You might want to do like a blue-green deploy where you take maybe 10% of your customer requests would go to the new version and the rest go to the old version, and you keep your eyes on the monitoring and you see, hey, there's something happening there, so you might want to roll back and so on. Now, all these things that I'm describing here are kind of provided to you out of the box. Like, for example, Istio would give you already a good head start in terms of monitoring, tracing, security. For example, you get for free a TLS, MTLS between instances in production. Like, let's say you have multiple services talking to each other in the back, and they would just talk over an encrypted channel with MTLS. Telemetry, you get all these traces coming out, like each time a service makes a request to another service, a telemetry, I don't know, payload is extracted, and you can visualize that in something like Zipkin or Jaeger. You get all this, all this kind of comes for free, but there's a cost there behind the scenes in terms of getting this deployed and getting it maintained and so on. But as soon as you have it deployed and your whole backend or your whole system fits into this architecture, then you're pretty happy because you have a established workflow, you have certain concepts that are defined there, and you can't stray away from those. Like, you have a sort of standard that you must follow, and that helps you a lot in terms of maintainability, in terms of not burning money for Amazon boxes that are not doing anything. You get like really well constrained memory and CPU. But anyway, Kubernetes kind of does that for you. Istio is more in terms of observability, security, and such. Not sure if that's enough to answer the question, but that's at least my knowledge of this topic.
Were there specific features of the Go language that you were able to leverage or make this whole process a bit easier?
Well, for example, if I were to think, I come from a C++ background, by the way, so if I were to think about writing this in C++, I'd go crazy. Like, I've seen someone implement a gRPC server in C++ and it's just horrid, like compared to what, a few lines of code here, we just initialize it and so on, and you assign some Go routine to it in C++, this would be maddening. Also, this is kind of efficient. Like, I've seen some articles from Instagram on how they use Python in production, and I can see they're hitting certain limits of the language and of the performance that with Go I haven't seen. But again, at the scale that I'm running at, I probably don't see many issues that are there. So it depends on what you use it for, but for this kind of small microservices, like infrastructure microservices or backend microservices, I think Go is a perfect fit, simply because the Go routine support that it has, like, have threading as a first-class citizen inside it with this green threads, Go routines. I think this makes things very easy to develop and reason about. And I've seen way fewer bugs, like memory bugs and so on, developing Go rather than developing C++. I've seen people play with Rust. For example, Discord published a blog article on where they were saying that Go was not performing well enough for them for certain service. And I'll take that criticism, of course. Like, always look at performance. If it's starting to perform poorly, you can look at alternatives. Also, the C part of Go makes it very easy to interface with C, with a C API. So for example, Nitro Lazy Raster. This is a Go wrapper on top of on top of new PDF, and this is very handy. Like together with Carl, Carl started this project, and we built this thing called Lazy Raster, which lets you do a distributed rendering engine for PDFs, and it doesn't have that much code really. Like most of it was around building various tooling that we needed on top of the functionality that we had. But you know, just wrapping up Lazy PDF is kind of the CGO wrapper of new PDF, and just wrapping this C code in Go and making it accessible from Go just made things very easy to build on top. And this is very performant, so we're very happy with this engine. Anyone else? Okay, I guess no more questions.
All right. Well, if you come up with a question later, go ahead and ask in Slack. I know Mihai's around there, and
I'll keep an eye on
yeah.
that channel.
So I am going to reclaim host, find the switch,
Gonna pause
and
recording.
raffle off a JetBrains license.